Now, this is second lecture of module 1, which is introduction to hydraulic and pneumatic systems, and in this lecture 2 we shall discuss about basic components, symbols and circuits. Symbols for fluid power circuit designs. What we have seen in the fluid power system, that consists of at least a source of fluid flow and power supply, actuators, flow conduits with connectors and control units. Depending on the functional requirement, accuracy in control, environment, safety, etc., various other components are added to a basic system. Like electrical and logic systems symbols presenting various devices and units, symbols are also used in fluid, that is hydraulic and pneumatic power systems. You know that for electrical circuit design we use the electrical symbols, resistance, capacitance, etc. In case of logic also different gates we used. Similarly, in case of fluid power we must use some symbols for designing the circuit. In this lecture, symbols will be presented with their generic name and constructional and functional features. Such symbols are standardized and framed by the engineering standard organizations of different countries and may have some differences in feature. Nowadays, ISO standard, that is International Standard Organization, are followed in general. However, the symbols presented here may not exactly match with the ISO standard. The problem is that ISO standard is not easily available to us. So, many symbols what we have followed here, those are used in mainly the books and published work. These are presented for the basic purpose of learning the symbols and how they are used in fluid power circuit. If we follow the internets, if we look into the symbols, that should be available to us, but in many cases you will not be able to download those symbols. Although if you look into the catalogs for different manufacturers, you may find there they have the components along with their symbols which are ISO standard, ISO symbols. So, to learn that, what we can do, we can open a manufacturer's catalog and we can see that what are the symbols they have used. However, it is also possible to procure the ISO standards, although those are very expensive, but many companies, many manufacturers who are even using the fluid powers, may not be the manufacturers using the fluid powers, they might have their own standards. And these ISO standards are based on the standards already we are being used in different countries. The constructional feature will be more understandable when the actual devices will be studied in details. Now, this circuit already we have studied. Here what we find that a load is being lifted by an double acting actuator and it is being operated by a directional control valve. Also a term is there 4/3 that I shall explain what it is. Then there is a pressure relief valve, there is a pump, the motor, filter and reservoir. Now, actual components are different from this, but we present the whole system by a circuit and these are here the symbols are meant, not the size. Say for example, the pump must be much smaller than the reservoir, but what we see that as if reservoir is small, pump is the big. It is not like that. The size we should use the minimum size. Sometimes it is also possible you can develop these symbols as an icon and then that can be imported to develop a system. Now, in the next slide what I have presented how the hydraulic circuit looks. This is also again not the photography view, rather this is drawn by the computer graphics and here what we see, say compare with this actuator looks like this somewhat and then this is the valve, directional control valve and then this is the pressure relief valve and this is the pump and this is the reservoir. However, this motor is not shown, whereas they slightly elaborate the reservoir is shown and also there is another system is shown which is to put oil inside. This what we can do time to time, it may be after 6 months, it may be after 3 months depending on the use, we can pump out the oil and filter it and again we can put inside to reduce the contamination. Okay. Now, as well what we find here as if something is there, this is sometime the inline filter through which the oil is further filtered before entering the actual system. This sometimes it is called high pressure filter, which is essential for servo mechanism or in some cases where the proportional valve is used, but we do not know yet what is proportional valve. We must have heard of servo valve, we must have heard of proportional valve also, but we do not know. We will learn that later. And this is nothing but a barrel through which oil is being put inside. Now, history of development of fluid power symbols. The fluid power symbols were developed gradually more or less as follows. Initially by Joint Industry Conference JIC USA in 1948. In my first lecture, as I told that after the Second World War, when the many devices was developed, we were need based. Some people they thought that we must standardize this, and then first they started standardizing those symbols by which we can design a circuit. At the same time, research was going on also to for the theoretical backup of the devices. Later, the American Standard Association adopted it. European Oil Hydraulics and Pneumatic Committee CTTOP revised further these symbols more universally and eliminated most of the English symbols in mid 60s. However, many countries using their own symbols. This is not very different, but you will find this is not also the same symbols. This means there will be some differences. So, for example, in India what we follow, at one point we standardized it, or the many industries who are using those, they are also developed their own symbols. Nowadays we can use the computer, we can develop the icon and we can use this, but at a point we had the templates, stencil, which we could use on the paper and we can draw the symbols for fluid power circuit design. Later ISO have revised the symbols for international use. Now it is recommended in every countries that we should follow the ISO symbols, and therefore manufacturers, they are now where they are describing their components using the ISO standards only. Now symbolic representation of a hydraulic valve. Now what we find that there are almost a square or maybe a slightly rectangular 3 boxes put side by side, and middle one is written 0 and left side it is A, right side it is B, and in this 3 compartment there are some arrows or some symbols you can say are there. Now what it is? It is directional or direction control, in short form either capital DC or small d and c, DC hydraulic valve, simply called as 4/3 DC valve. But what is 4/3? In details it is 4 way. What we find A, B, P and T, there are 4 way or 4 port, and then these 3 compartment means there is a 3 position. That means we can get either this type of connection, cross connection, or we can have straight connections, or we can have these 4 ports are completely closed. Now in details we should call it 4 way 3 position direction control closed center hydraulic valve. What is closed center? If we look into this, at this position, that 0 position, which is called neutral position, these 4 ports are closed. Now always when we are using 4/3 etc., the first comes the number of ports, that is 4 means number of ports or ways, and then comes number of positions. Now development of symbolic representation of DC valve, that is direction control valve. Example of construction of a DC valve symbol with icons. Now this is a simple icon where it is written 0. Now we have another icon, here it is A. These are not icon, just a box where we will present the icon, ultimate icon, and then we put A here, and then another we take a B and then we put it here. So these are not exact icons, but I would say that these are representing icons, and then we can choose these 3 to even more icons, and we can construct a valve for the directional control. Now, in these 3 compartments, middle one is the neutral, and for neutral one we can choose say either this icon or this icon or this one or this one. Now, this one is full closed center, that means all the ports are closed when it is in neutral position. Contrary to that, if I use this symbol, this will full open center. Now, this means that in middle there are A B ports which can be connected to two sides of the actuator. One is input, another is output, or vice versa for the reverse motion. Whereas P indicates it is connected to the pressure, that is pump. This P actually indicates pressure, not pump, but we can say it is connected to the pump, and T is to the tank. This is for the drain. Okay. Now, if I again judge into these icons, then look at these icons. This is that P is normally remain closed at neutral position, whereas other 3 ports A, B and T are connected together. This means that if we imagine when it is connected to the actuator, then at this position, neutral positions, this load will come down, oil will go to the tank, whereas this pump, if it is running, that will always remain ready with pressure. Definitely if pump is closed, that means delivery side is closed, it will develop a pressure beyond the pressure we are utilizing for the system, and then this oil has to go through the pressure relief valve. Question is that why we are keeping this pump ready, why we are running the pump when the load is not being lifted. Actually, in many cases we need this actuation system very often, that means on and off, load is being lifted, again coming down, again being lifted, and in that occasion it is better to keep this oil ready for the operation, and it is beneficial than starting the pump and again lifting the load. It will take more time without much saving the energy. Okay. Now, if I look into the fourth one, what we find, this path, the supply path in one port and the pressure path is closed at neutral, whereas the other one is connected, 2 ports are connected. In that case, we can imagine when we put into the neutral, automatically the load will come down if we look into the initial circuit which we have already studied. Now, if I consider the icon for A and B, then it is like that pressure port is connected to B, in this case the left one, and the port A is connected to tank. That means the supply is going to the B port and oil from A port is coming to the tank. Now, A B, this does not mean that one has to connected the large end of the piston, and other is the rod end of the piston. It does not mean any one can be connected to any side, but definitely both are not connected to the one side. Now, if we choose this one, then we have to choose the other one, which is straight connection, that is pressure port to A and B port to tank. Now, if we use this as a B and if we use this one as a and say this one as a O, then we should call this one 4/3 position directional control open center valve, hydraulic valve. Now, one thing I would like to mention that pneumatic valve also will look more or less same, but there is some other symbols is added to this to understand that what is pneumatic, which one is pneumatic valve and which one is hydraulic valve. So, we are now only discussing on the hydraulic valves. Now, if I look into a details of this valve, how it looks like. Now, what is this one? This is a spool, from this point to this point it is a spool. Now, this is a circular one, this is a cylindrical one. As you find, this is a, this stem is of lower diameter than this one, again it is up to this hole and again it is lowered, again it is up to this hole and then lowered, and these two side may be cylindrical or may be flat type. Now, there will be some connection by which we can move this spool this way or that way. Now, how it is connected? Look into this. This is P, pressure port, it is connected to the pump and then oil is coming over here, but oil cannot go any side at this position of this valve, which is the neutral position. Similarly, this port B and A are also closed, as well as this T is closed in a sense that this has no connection with, it has connection to the tank, but it has no connection with the other ports. Now, if we move in this way, then say rightward, then P will be connected to B and you will find A will be connected to tank. Similarly, if we push in this directions, then P will be connected to A and B will be connected to this path, through this it will go to the tank. So, this is the construction of closed center valve, all ports are closed at neutral positions. Now, if we consider the open center, you can see just this spool is changed. In this case, the P is connected to the all ports at this neutral position. Now, if I move this in the rightward directions, then P will be connected to B and A will be connected to tank, and if I move in the other direction, it will be reversed. Now, this is called tandem center. What is in tandem center? In tandem center, that oil at neutral position is going to the tank directly, whereas these two ports are closed, right. Now, if we move in the right directions, then P will be connected to B, but look at this, this path will be closed and then A will be connected to T, and it will be reversed in the, if we move in the opposite directions. Now, if I discuss over the closed center and open center, definitely one is used to other for some benefits. I will discuss that in this section as well as later in more rigorously. However, before that we should consider the other type valve. There are other options also. In this case, as we see that at neutral position P is closed, but all other are connected to tank. Now, as you move in this directions, P will be connected to B, A will still remain connected to tank. whereas if you move in the opposite directions, A will be connected to pressure port and B will still remain connected to the tank. Okay. Now, if I put all together, then open center is useful for energy saving. That means, oil not, if we discharge the oil through the relief valve at pressurized conditions, too much heat will be generated. So, all the power will be lost through the heat energy. If we use the open center, definitely this pump oil will not be pressurized and it will only circulate, it will go to the tank. So, oil will remain cooled and there will be less power loss. Definitely it is benefited, but why then we go for other valves? The reason is that in this case the oil which is being pumped is not ready with pressure. So, this system we normally we will use where we may not need very quick action, as well as these operations is being done after certain time intervals. In comparison to that, if we go for the closed center type valve, in that case oil is always ready and whatever the condition of the system after an operation, that will remain as it is. Say for example, load is being lifted half the way. Now, we have put back the spool to the neutral positions. So, the load will not come down. However, there will be leakages. So, it may come down slowly, but there are standardization of that too. So, general applications, it might be, say, it might be allowed that 1 meter in a day, sorry, whereas in military applications you will find their specification is that maybe 1 centimeter in a day. So, depending on that, accuracy of this valve is maintained and selected in that way, and definitely for more accurate valve cost will increase. Now, similarly, if I go to the tandem, which is mostly used, a tandem is that we can keep the load position like that at the midway, whereas oil is being not through the relief valve when it is in neutral position. So, energy is being saved. This means that we would say then when we need very quick action and intermediate position of the load, we shall go for closed type, whereas if we think of that we can use this saving the energy, we will go for open type, fully open type, but in most of the cases you will find tandem type is might be the best one for common applications. However, the cost of this tandem valve is more. If you look into the spool, you can see inside the spool there is a hole, and through this hole oil has to pass through this hole, there is no other way. So, cost of this tandem valve is more in comparison to this closed type or fully open type. Now, here we have only mentioned that this can be moved, we have not discussed how it can be moved. Sorry. Now, symbolic representation of few other direction control valve. Now, with these two icons, what does it mean? Definitely this is 2 by 2 DC valve, 2 position and 2 ports and 2 position. So, these are used as a on off type, there is no neutral positions. either you put it here, path is closed, or you put it there. So, this is simply on off type. Now, if I look into this, what should be its name? So, first we should call how many ways are there, how many ports are there. So, definitely it is 3. Now, as the 2 icons are there, 2 blocks are there. So, this must be 3 by 2. So, this is 3 by 2 DC valve. For this position, the pressure port is closed and the system port is connected to the tank, whereas for this position, tank position is closed and this oil is being supplied to the system or actuator. Now, looking into this, what should be the name of this one? This is also directional control valve. Definitely there are 3 positions what we find, but how many ports are there? 6 ports are there. So, name of this valve is 6 by 3 DC valve. Now, what is it? It is in neutral position. I have written as a S1 and S2, S1 and S2. What is S1 and S2? That is perhaps it is going to a some other system. But if you put in this position, right position, then this S1, S2 will be disconnected and P will be connected to A and B will be connected to T. And if I put in the left side, the cross connection will be there. That means P will be connected to B and A will be connected to T. So, this valve in lieu of 4 by 3 DC valve is used when this flow is going to some other system. This means that there is a external connection P to S1, okay. Pump is connected there. Now, symbolic representation of DC valve, we are still continuing. Now, so far we have not discussed what is driving the spool and how the spool position is controlled. Control means at a certain position, if you want to maintain the positions, how it is being done. Now, in this case, what we find away from these 2 icons, one side there is something like M, which is nothing but spring. You can understand this is a symbol of the spring, and left side there is another rectangular block where is arrow and there is one dotted lines. Now, this is 4 by 2 hydraulic pilot operated spring return DC valve. What it is? That if I look into this, this is a, this symbols indicates this is being operated by an hydraulic. Now, this line, consider that some signal is coming there and it is, this symbol is for hydraulic signals is coming through this, and as a whole it is called pilot operated. And then if we off this one, then automatically this spool will go back to its this position by a spring. So, it is a spring return. That means, if this side is off, no signal is there, then it is working with this. When the signal will come, then it will go here. Okay. Now, this is another valve, and what it might be, we have seen this one, the first one. Then what we find in the side B also more or less same symbols are there. Then this is 4 by 2 hydraulic pilot operated hydraulic pilot return DC valve. This means that in both the side there are the hydraulic operator, hydraulic actuator to operate this spool. If we actuate A, if this A signal, then it will go to this position. If there is a B signal, this will be in this position, or no, it might be the reverse. If it is there, then it is here, or if this signal is there, this is there. Now, this detail can be understood from the looking into the actual valve. Now, this is another valve. In this case, what we find, as if this and this is the same, the first one and this third one is the same, but instead of this signal line, we find there is another block with a inclined slash is there. Now, name of this valve is that 4/2 solenoid pilot operated spring return DC valve. This is spring return, the first one, the third one is also spring return. So, this feature is same. Instead of the hydraulic signal, in case of first one, here there is a solenoid, that is electrical solenoid is there to operate this side. Now, if I look into this, this is more complicated. This is definitely 3 position, but there are 4 ports. We find there are spring, we find also there is a hydraulic actuation, hydraulic pilot is there. So, we can perhaps name it like that. This is, let us see whether I am correct or not. We can say 4/3 hydraulic pilot operated spring return, and this is partially open center DC valve. Let us see, this is 4/3 hydraulic pilot operated spring centered. When we put the spring both the side, we call it spring centered. When we put the spring one side, we call it spring return, and A and B open to tank DC valve. Instead of partial open, it is specified A, B open to DC tank. Above symbols are full representation with spool drive symbols, signal, connection, etc. So, this means that when we select a valve for our circuit design, we should use these symbols. Now, here I would like to mention, if you look into the symbols of hydraulic systems, there are many symbols which is very difficult to remember, and neither you need to remember all these things. But the purpose of this study here is to that if you at least go through few times with this valve, you will have some idea. Say, looking into the construction of this valve one by one, we can perhaps understand another valve, how, what it may be. Okay? So, basic purpose to learn this valve, not to remember all these things. This will be available from either from the for the circuit designers in a company, they have their own valve symbols. You can go there, you can call it, or knowing into the application of the valve, if you select the valve, there you will find the symbol. Spool may be driven again manually or pneumatically. So, in that case what we should, so this is the hydraulic symbols. Similarly, simply in many valve symbols you will find that instead of this arrow, it is put there and it is written man, that is manually operated, and if it is put there and pneumatically. Valve is hydraulic valve, sorry, and but the spool is being driven by pneumatic power. Now, symbolic representation of other valves. So, let us consider the most important, the pressure operated valve. Now, if we look into this symbol or this symbol, then this is a direct acting pressure relief valve. What it is? Say, let us study this one. What we find, this arrow is here, and as if there is a in and this is drain and this is spring, that means spring is pushing this one. Now, from here if a signal comes, then if this pressure rises above some limit, then this will come here and this will be directly connected. So, this is a direct acting pressure relief valve, you can say this is a direct acting, means when the pressure directly pressurizing this poppet to open this one when it is crossing the pressure limit. It might be of this symbol. In fact, if you look into the pressure relief valve symbols, there are many other symbols are also used. Now, ISO has standardized one, and probably this one is the close to the ISO one. Now, what is the difference here? We find in this spring direct acting pressure relief valve with limit pressure adjustment. That means, in this valve we can adjust this one, this spring strength, to limit the pressure. Now, if I look into these two valves, this is looking alike, not much difference, but the above one is the pilot operated pressure relief valve, internal pilot and external drain. In this case, pilot operated pressure reducing valve, internal pilot, external drain. Now, what is pressure reducing and why it is called pressure relief? Now, in this case what we find that this is connected to the supply line, in line, not the output line. So, this signal is coming from the input side and this is used for pressure relief. Whereas, in this case if we find that the pilot line is connected to the output side, then definitely this is some regulating some pressure here. Now, apart from that, this is again hydraulically and this drain is external, but here we have put some X on this line. These are not X, actually this is the closed port, but if this is opened, then we can also generate external signal to operate this one. Do you understand my point? This is internally connected to the pressure line itself. However, we can remove this and completely we can control through this external, then we will connect to this. Say for example, another system is sending a signal to operate this one. Now, looking into this valve, what might be the possible name of this one? Now, this is pilot operated pressure relief valve, internal pilot, internal drain in this case, and pressure reducing valve as well, fixed and variable adjustment. These are combined valve. There is a valve where we can regulate the pressure, we can reduce the pressure, and it can be used as a relief valve as well as the pressure reducing valve. Now, symbols for pumps and motors. First of all, I will discuss about the rotary pumps. Now, here I would like to mention that so far what I am discussing, that is only a few examples. You will find there are many other symbols also. In fact, you will be given a few pages where the symbols are there, that is from a book, I will mention later. Whereas, in case of this will be available also if you go through the web lectures of this one, and there it is given as a appendix. Now, coming to the pumps and motors. Now, what we find here, there is a circle and inside there is an arrow, and this arrow is completely filled, it is looking black. Now, filling this arrow has meaning, it is for hydraulic this arrow is filled, and in case of pneumatic this is kept blank. Okay, just a triangle is put there. However, this pneumatic pump is different, rather it is a compressor, the symbol is different, will come later. So, looking into this one circle and one arrow, we should call it constant flow pump, single output. Okay. Now, if we have two arrow, then constant flow pump, double outlet. Now, how it is possible? A pump is single outlet, maybe constructional feature inside same. Now, this might be achieved if we rotate this in opposite directions. This is one option. Another option is that this is fixed displacement, but inside there is such a arrangement keeping the direction of rotation same. If we actuate that one, this flow will be from the other port. Okay. Now, on the first one, if we put an arrow, this indicates variable flow pump, single outlet, and if we put an arrow with the second one, this will be variable flow pump, double outlet. Contrary to that, the motors will be that arrow are toward the inside, toward the center of the circle. And if you see this name, this is a constant flow motor, unidirectional, this is bidirectional. That means here rotation we can, if we change the rotation, then the direction will change, flow into out and out to in, like this. Similarly, this is the variable flow and this is the variable flow motor, bidirectional. Now, instead of flow, the term displacement is also used. Sometimes we use constant displacement or fixed displacement pump and variable displacement pump or variable displacement motor. Now, this is in this symbol what we find as if there is a pump as well as motor. Now, this is hydraulic pump, definitely if looking into this symbol, again it might be a motor also. Now, rotation one way only. What does it mean? That suppose it is rotating clockwise, if we rotate the shaft, it will act as a pump. If we allow the oil to go in, we can take the output from the shaft, then it is motor, but the direction will remain same. Okay. And what we find, this is a fixed displacement. Now, if we come to this one, this is hydraulic pump or motor, rotation dual directions and displacement fixed. What does it mean? In this case, only direction of rotation is one direction, say it is clockwise. In this case, we can use at clockwise as well as anti-clockwise, and for that rotation again it is either pump or motor, depending on whether we are supplying the flow or taking out the flow. Now, if I add these two arrow, then this will be variable displacement. Okay. So, these are the few basic symbols of the pump and motors. Apart from this, you will find many other symbols are there depending on their operations, but most popular are what I have put, that 8 at the top. Okay. Now, symbols for basic components. So, this is a reservoir and we find another line here which is baffle. What is there? The oil, main oil will come here, or maybe the return oil is coming here, then this will go over this with some contamination will be kept here, as well as the foam inside will be reduced. So, baffle are also used. So, that details you can learn from any book. We shall not discuss much more on this, how the tank is constructed. Now, this is a filter or strainer. Usually we need a, when we put inside the tank suction side, we call it strainer, and if we put it in the return side of the oil, then we call it is filter. Now, this is when we use this symbol, this is an electric motor, but as well we can write PM, that is prime mover. Okay. Now, this is the symbol for pressure gauge, this is the flow meter, and this is the check valve with spring, whereas this is accumulator. Accumulator means you can store energy here, we will learn it separately in a lecture. Then this is cooler and this is heater. This symbols more or less same, but as you see this arrow is outside means heat is going out. So, this is cooler, and in this case heat is going in. So, this is heater, and also sometimes this symbol is used. In many cases you will find, particularly for experimental setup, we need a quick release coupling. This coupling, if you just take it out, then path will be closed, no oil will go out. Even if it is pressurized oil inside, you can simply open it to disconnect and close it, again it will be connected. When we will come to our lab, we will show this what it looks like, and this is an check valve. And then for pneumatics, as you see, this is the double acting cylinder and this is the rotary actuator. As you see, this arrow are not filled in, but as well this is not a full circle also. This is actually rotary actuator, means this is not compressor, rotary actuator motor. Now, pressure regulator valve looks like this in case of pneumatics, and pneumatic we need the filter separator, it is called filter separator. Now, this is a direction control valve, as you see 3/2 DC valve, but looking into this arrow and this symbol, you can easily identify that this is a pneumatic, not the hydraulic one. Similarly, 3/2 solenoid flywheel operated DC valve with detent looks like this. Now, again I would like to mention, usually while you are designing the circuit, not the pneumatic, but the hydraulic, these colors are used. You may follow this. If you are well conversant with these colors, then looking into the circuits, if it is colored, you will be able to understand where pressurized oil, where drain, where leakage, where control, where is intensified pressure is there, and there is inactive fluid as well if it is a blank. However, in mostly very rarely we use this circuit, but in many cases you will find manufacturers while they are describing a circuit, then they use this color. So, this you can keep it with you to understand a circuit. This should be by the side of your hand to have a knowledge on what is what. Now, here with using such colors, now this is a valve, as you can see. This is restrictor type pressure compensated flow control valve. What is pressure compensated? In valves, it is there that if pressure is increased, then flow is reduced. Now, this is we will study in details when we will come to the valve side, but as you see why I have shown it here. If you look into this valve, then these are symbolized like this. If it is with a check valve means it is the flow is in only in one directions, and this is a flow control valve. We will use this symbol. If it is without this non-return valve, then we will use this one. In fact, this valve is without non-return valve here, and as you find this side is a pressure relief valve and pump is there, this is a pressure gauge, and other side you find a cylinder is there and there is a pressure gauge, and we can control the flow here, and if there is a pressure set, automatically this flow will be controlled. In some cases, with the increase in flow, with the increase in pressure, the flow will automatically stopped. Now, if we look into this is 4/3 DC valve, but this is a rotary type. These are not normally used, but still at one point this valve became popular. In comparison to this, the spool valve has better leakage property, that means less leakage with that spool valve. There will be here it will be more leakage, but this is easy to operate. Now, functional feature and symbols 4/2 DC valve. As you look into these two figures, this looks alike, but if you look into the symbol, these are different. And if you study a little bit, say in this case the oil is going directly to B, and then this is stopped and this is stopped, whereas oil is going into A side, then these two are stopped. In this case, while oil is going to B, still A is open to tank, and it is vice versa. Now, this is a very simple circuit is shown with a direction control valve. This is as if on off, not on off type. This is two position, you can say, either it is going straight or it is going in the opposite directions. So, this circuit, to understand the operations, we can present it like this, but for general purpose we use the symbols. Now, these symbols, as I told that it is not from the ISO, we have followed this book, Fluid Power and Microprocessor Control, an introduction, E.W. Reed and Lerman. So, this symbol will be available to you, I shall give you later, and thank you for listening.